Hey guys, this is Jacob Fabizak. My group was the water table injection system. The group members were Brett Watson, John Millar, Clark Hawkinson, Dane Kelsey, and myself. Our sponsor was Dr. Brian Lewis, and our faculty mentor was Seth Martin. We completed this project for the mechanical engineering department for our senior design project. The requirements of the system that we designed were that the device needed to inject dye continuously and pulsed, the dye needed to be clearly visible in the water, and the water velocity needed to be measurable using a cell phone. The device had to have multiple injection points and needed a large enough reservoir to be able to just be filled once at the beginning of class and then not need to be refilled. Our design idea was to have a storage tank for the reservoir, an Arduino for the controls that goes to a motor and then to a manifold, which then feeds the dye into the injection points, which are going to be needles, while having a grid for the background, a black light to help light up the fluorescent dye, and a phone mount to hold the cell phone so that you can get good data from it. These are some of our prototypes that we went through. We had three prototypes for the mounting of the injectors, as you can see in the pictures on the left. And then we had two different versions of the circuit, one that we prototyped with a light to make sure that it would be sending the pulses that we wanted to the motor. And then we also had various prototypes for the background. We tried some with white paper and black paper. These are some pictures of our testing of the various prototypes. We learned that we wanted to use a black background with white grid lines and that we needed to have a very powerful black light to help aid the fluorescent dye. And we also tested what pressure we were going to be needing in our reservoir in order to get the dye to flow smoothly. As you can see in these videos, we were able to get the pulsing ability functioning, and it was working very well for us. And because of that, we were also able to get the continuous flow functioning. These are some photos of us assembling the final system and putting it all together. And then these photos show the whole system put together and how we are going to store it, because that was another one of the requests, was that we needed to maintain the current storage space and not make it too large. So some things that still need to be revised are there needs to be an elimination of the excess drip that occurs after the pump has been shut off. And then there are some parts that still need to be 3D printed due to the parts being too large for our personal printers. And then the injection timing in the code needs to be tested and adjusted to achieve the desired flow pattern. All of these things could have been finished if we were not hindered by the lack of access to the facilities due to the coronavirus.